type of class, and I want to kind of go over this. Um, so first of all, how many different tests you already learned? You learn as n term, so n term divergent tests.
What's what? Oh, the first test we learned. Yeah.
The second is telescope.
That's the lamest one. What? It's honestly, yeah, it's the fun.
And
it's
usually has to do bottom is usually with two fractions. Okay, so you have a two fractions, right? Or you have to decompose, or a natural log. Sometimes you got natural log. It's also telescope, so you gotta be careful with those. Third, you got geometric. I think at this one, these two are the one that you actually can get a sum. You actually can get the infinite sum between telescope and geometric. That's only two you can actually get a sum. Does that make sense?
You can do what? Telescope.
Um, you can actually get actual sum. So let's say, so this one's gonna be a1 over 1 minus r, and this one just you have to write out all the term, eventually lead to a lot of canceling. So this is sum equal to that. The four things that we learned, I just want to review all the things. Four things that we learned is integral test, integral test, and an integral test must have three conditions. What is three condition? CPD.
Decrease.
According to Harman, it's a cripple, poverty, and depression. Okay, so in order to integrate tests, that can get very close to the sum, but they're not an actual sum. They are very, very close. They are almost very, very low error on it, but you can get pretty close to it. Now we have learned direct comparison tests, and we also learned about limit comparison tests. So in this case, oh, also there's another one. My favorite one is p-series.
That's the easiest one.
Yeah, it's the easiest one. So my favorite one is always p-series, and we also know other than that, harmonic series is always diverge. But we're gonna come back to talk about harmonic today.
Well, yeah, we usually use p-series to prove LCT.
Okay, so in this case, you'll compare with summation n equal to 1 of infinity, and you only pick the highest power here. Now, why do I do that? Because it just makes a lot more sense, because n cannot compare with n squared, 3 cannot compare to the n to the q, and this one is going to be simplified down to 2n squared over 2n to the 7 over 2 when summation is equal to.
If we want to, can we just not ever have coefficients either? Like just the ends matter, right?
Yeah, but I just work it out so that way I can be sure. So it's a 1 over n to the 3 over 2. Now this one is converged due to p-series. So p-series. Then you had to compare this, so it'd be 2n squared plus n over square root of 4n to the 7 plus 3 divided by 1 over n to the 3 over 2. If you keep change flip, so it'd be limit n approach infinity of 2n squared plus n over square root of 4n 7 plus 3 times by 1 over n to the 3 over 2.
Wouldn't be the opposite?
Yeah, the way around then.
Yeah.
So n to the 3 over 2 over 1. So therefore, it's going to give you limit n approaching infinity. It'll be 2n to the 7 over 2 plus n to the 5 over 2 over 4n to the 7 plus 3. Now I'm going to divide it by top and bottom by
7 over 2.
N to the 7 over 2. N to the 7 over 2. This one is n to the 7 because inside the radical is over 2, n to the 7. If that's the case, it'll be limit n approaching infinity. It'll be 2 over plus 1 over n square root of 4 plus 3 over n to the third. To the 7, sorry. Therefore, it's going to be 1. So when it equal to 1, limit comparison test says limits summation of n equal to 1 to the infinity of this ugly thing of 2n squared plus n over square root of 4n to the 7 plus 3 is equal to converge.
Wait.
Oh, so for limit, as long as the limit isn't undefined, for limit comparison test, as long as the limit is not undefined, it's converged. Sorry, it's whatever the thing you compared it to.
It's always equal to L. L is a constant. In this case, is equal to 1.
Yeah.
If it's equal to 1, then you just says, well, if this series you compare with is converged, therefore that's converged. It's not because that 1 makes it a converge or diverge.
No, I understand. It's whatever you compared it to, it's gonna be like that thing.
Yeah, it's gonna be the same solution as
Yeah.
that. Okay, so in this case, it's converge. Now with the next situation, you might get something like this, and you can do that as a homework. And just like what would test you were expected. So in this particular case,
yeah,
you're still gonna use a very, very similar test, and it's gonna give you a similar result. So I'm not gonna lead to that, but you can do it as the work when you do it at home. This is a more complex one that where you have to do limit comparison test. Eventually, you're gonna get the same thing. You will get a converge in this situation, but you do have to show the work. Now, just like Andrew says earlier, Andrew says, you know, I'm probably not going to show too much work, and I cannot give you credit without the work. Unfortunately, that's what I'm going to say. I can, if I don't see what you compare it to, I mean, you don't have to show as much as work I do. You do have to show is P series happen. You do have to show what happened. You have to show limit comparison test, at least this part. And if you simplify a lot of things, like going straight from this step to this step, that's understandable. And then that way I can tell you, okay, this, you got everything. And you have to tell me which kind of test did you use on your test. Otherwise, I have no idea what did you use. I'm not going to assume something. You're going to have to tell me which test did you use. You can shorthand. LCT, DCT, telescoping, geometric, integral test. You can shorthand certain things. With DCT and LCT is probably going to be one more thing. So today we're going to talk about one more series that it's going to be a little bit different.
Well, isn't that a problem?
So today we actually talked about
Okay.
alternating.
Alternating series? That's divergent, right? I don't oscillating. What, Jordan, what? No. That's that. Okay. Jordan, was playing it this morning in that show. Yeah.
Okay, so I'm going to try to come up with this one. This one's you know what's the last famous series that you're supposed to know?
Fermi theorem. Oh.
Oh, it's the one on the.
Oh, the harmonic?
Harmonic. Good.
That's just 1 over n.
Harmonic series is very, very famous series. You can get a 0 on the test. If you don't know harmonic, at least know that one. That one is always diverge, okay? If you know nothing, harmonic always diverge in this case. You can prove by using P-series. You can proving by just common sense by looking at the write out all the term. However, I'm going to show you the next one. It's not harmonic. It's very, very close to harmonic. So harmonic, there is one is called alternating harmonic series. Okay, alternating harmonic series. So, and what is the deciding for alternating? So I'm going to show you. let's just say n equal to 1 infinity of -1 to the n minus 1
Divergent.
over n.
It's divergent. It's not allowed. Unless.
Think about it.
Yeah, he's gonna be like, well, actually, if you did a LCT, the thing you compared it to would be 1 over n, so it has to be divergent. And I'd be like, come on.
So sorry, I'm gonna kind of move this around a little bit. I'm gonna give you a definition first before I give you everything. So definition is gonna be this. The first thing is, in order to use AST, you must be alternating. So let's just show you here. It says let an is greater than 0, and it has to be the alternative series. So the alternate thing series either can written this way, n equal to 1 infinity, or something that's really close to this, which is the most important, is the -1 to the n in the front. That's called alternating. And this n equal to 1 when it goes to infinity of -1 to the n plus 1 to the a to the n. So what's the difference between first series and second series?
One of them starts out negative, the other one starts out positive.
Good. So then if those both will converge if the two conditions true. If two conditions are met. It's actually 3 conditions, right? First condition, it has to be alternating. But 2 major conditions after alternating is the first one is limits n approach infinity of a to the n is equal to 0.
Well, that makes sense.
So they must equal to 0.
That's like nth term test, but you can prove convergence if it's alternating.
Oh, that's not nice.
2. It's a to the n plus 1 is less equal to a to the n for all n.
Wait, oh, okay. The big one's less than the smaller one. You know what? That makes sense. Well, is it like the absolute value of the bigger one's less than the absolute value of the smaller one?
No. Here we don't care about, it's not absolute value. It's not because of absolute value, because we not care about -1 to the n right now. We just care about a to the n, which is just actual functions.
The actual
So-
function without negative?
Yeah, so the negative, we always exclude them because we don't have to worry about those. And I'll give you an example. So are you sure? All right. So what we're gonna do is we're actually gonna do this question. This question is not harmonic, but instead of harmonic is alternating. Okay. Andrew, are you playing League of Legends?
No. You can't
No.
play that on your phone. I don't think.
No, remember they
You can.
came out with like the new Rift game?
Oh, yeah, I remember that. Very
No,
good
I'm
game.
playing I'm playing
Very good
Marketing
game,
Monsters. I'm a real gamer.
I actually keep playing. I got Fortnite dub last
It
night.
only takes a little.
Okay, so this is equal to 1 plus minus half plus 1/3 minus 1/4 plus 1/5. Dot 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 dot.
Yeah, I know what you mean.
Okay, so this is a very famous. It's called alternating harmonic series. It's always converge due to ST. AST, which is alternative series test. And I'm going to show you that's true. So first of all, it's alternating. Check, right? That is the first condition. They change it between -1, positive, negative, positive, negative. Second one, if limit n approach infinity of just the function, which is this one is 1 over n. So in this case, 1 over n, that's equal to 0. If it equal to 0 is what? The condition also met. Yes. The third thing is as what? Is a to the n plus 1 is less than a to the n. So 1 over n plus 1 is that less than 1 over n?
Yes.
Yeah.
Would be. Yeah.
Yeah.
What was this?
It's like the actual.
No, yeah. The first one, like we just didn't include. Like you just have to know it's alternating.
Okay, so remember this one you can use the compare to the an plus 1 less than a to the n. Second way to testing this, what does this actually mean? This means decreasing. Why is decreasing? Because your next term is always going to be greater than the it's going to be it's going to be your next term is always going to be less than prior term. So if this is true, you can also using derivative to test. So first way is to test is an plus 1 less than a to the n. Second way to test is using derivative. Okay, so in this case, I can use the an to plus 1 because it's really simple. I can cross multiply. That's going to be n is less than n plus 1, which is true because when n is greater than 0, if you plug in 1, and you always going to be infinity. Now, or you can take a derivative of the function of f of x equal to 1 over x. F prime of x is going to be -1 over x squared. If you do number line test between 0 or between 1, sorry, I'm going to say 1 to infinity, this one is always going to be negative, so therefore it's decreasing. So you can choose to test this way, the eighth way, or the b way. I usually prefer to go the b way just because I think derivatives are much more accurate. It's really harder to prove more complex fraction with n plus 1 and n. It's really hard to prove that. So I'll just do this. So does this make sense? If you have 3 of those conditions, first condition has to be alternating. Second condition, limit has to be approaching 0. The third condition is what?
Decreasing.
It's decreasing. Decreasing can prove in 2 separate ways. You compare to the n plus 1 and n, a to the n and n plus 1, and then or take a derivative, find out it's all negative, then it's always going to be the thing. In this case, the alternative series is converge. With the next thing that we're going to say, well, S1, right? We're going to use 10 spaces. Hold on.
Is it the same series test?
No, we're going to just show you what happened.
Wait, is that over to us?
So this is a S1 if it's a 1, right? And just think about this 10 spaces 1.
What do you mean?
Okay? Now remember the second term is 1/2, right? So it's minus 1/2. Would it take you to go backwards to get here?
Yeah.
And this becomes a S2. Does that make sense?
Yeah.
And the next one is what?
410. But like 4.
1/4, right? Because no, 1/3. Because you got 1/2
Oh.
and then 1/3.
Question.
1/3 is roughly like going to here.
That'd be 1/4.
This is about 1/3, right? This is S3. Are we okay here?
You're just showing us visually what the.
And 1/4 is gonna be about 2.5 spaces, so it's about here. So this is S to the 4th. And then 1/5 is about 2 spaces, so it's gonna go here. So S to the 5th. about 0.2.
They're just gonna hold in.
And 1/6 is going to be here. And eventually, it's going to going back and forth, back and forth, back and forth, back and forth, and back and forth. It will be confined into one small spot.
Flaps.
What is it?
I don't think we can prove that.
It's
We don't know what is it. We don't know what is it, but we know it's going to be converged. But we can tomorrow we can find out what happened with a small error. We can approximate it's between two values. Okay, we cannot decide like what exactly the value is. We know it's going to be decided by if it's infinite, it will go to a specific places. But it's non-infinite. It's kind of squeeze theorem. It's squeezed between two things, and it's going to be between two values. So
0.7.
I don't know. Well, I don't know what is it, so I'm not going to be able to tell you. So, with that being said, that you know that harmonic eventually will go to the converge due to like visually understanding. Visually understanding. So you go in 1, go back a half, and go in 4th, 1/3, and come back 1/4, and going back 1/5, and come back 1/6. And eventually it's gonna be like getting small, 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 small. Eventually it becomes a infinite sum. Is gonna be a converge. Is that okay? If it's infinite,
I
okay?
guess that makes sense.
But so what we're gonna do is I'm gonna give you a couple of examples. Ask you to try to prove this harmonic is things. So the first example I'm gonna tell you is this one.
Is this
It's
the homework?
summation of n equal to 1 of infinite of -1 to the n of 2n over 4n minus 1.
divide and sitting by.
Actually, yeah.
You're just eating. It's not like you're writing anything down. Fatty.
Oh, that's not very nice.
Okay,
That limit sure looks like
this causes
looks like 1/2.
I was trying to point you to the board. It says your name.
where?
Yeah.
Well, maybe.
Okay, we can't do anything.
I thought maybe Will.
Oh, I
got an idea.
No, it has to diverge because the limit is like 1/2.
The people gonna join competition to compete with Orlando Science. Maria, you wanna go? This Saturday.
Oh, I can go.
You wanna go?
What time?
Are you 100% going?
I don't know. I think Katie wanna go. I think I was convinced Katie to go.
100% going. I actually have
Yeah,
a
I think you have
ride.
to audition
Take me
for
and
a
I'll
music
go.
minor.
What time is it?
Huh? In the morning.
The morning? Damn it. We have practice.
Sure, you wanna go.
We do have practice.
Yeah, actually,
Yeah, but you
vocal
won't wanna
definitely has
go.
to do that.
Would you?
Yeah.
You would?
Vocal club has a different set of rules than the intro.
What? Yeah. Math competition?
Yeah.
I thought you wanted to go to that for so long.
Like,
I've
I
never
would be
been.
willing to go. Fine.
It's-
I like math.
It's
I like competition.
pretty competitive. Especially team is very competitive. But
I just want a minor.
Luke is a freshman, finished BC Calc.
Okay.
That's fair.
What a loser.
You are a loser. You didn't finish until senior year. So who's a loser now? Okay, is this alternative series test work on this particular
No.
case?
No,
Why?
the limit's 1/2. It's not 0.
Okay, so it's alternating. Check, right? That's the first one. Second one is if limits n approach infinity of 2n over 4n minus 1. This one is equal to 1/2, so therefore it's diverge. If it's diverge because it's not equal to 0, so therefore the AST fail. And you don't even need to do the third test, and if you want to be good with doing the test, you can actually take a derivative of this, which is f of x equal to 2x over 4x minus 1. And if I take a derivative of this, then that's going to give you low d high minus high, D low.
Over low low.
Over low low.
What does it mean?
Don't forget the low low.
That was the
The
fair
test
part.
failed, so what's it mean?
The test failed. That means the alternative series test does not
No, don't
work
put that
in
in your
this
eye.
particular case.
Should we use a different test?
That's not good.
No, it doesn't work.
I've had that
Just
before.
fail. It's gonna be diverge.
Oh,
Well, you're gonna end up going to the doctor.
So in this case, it's gonna be ax minus 2 minus ax
Oh my God.
4x minus 1 to the second power. So this will cancel out. That's just negative 2 over 4x minus 1 squared. Now, remember, you only do the test after 1, right? So if you plug in 1, the 4x minus 1 squared is always positive, and negative 2 is always negative. So it's negative, so decreasing. So therefore, third condition is actually passed, but the second condition failed. Therefore, alternative series test does not work. So in this case, it will be diverge. Any questions here? Okay, so I'll give you another one, but the next one is a little bit more tricky. So this one is actually called professor actually give.
What would we do if it failed? Like on the test?
And just diverge.
Okay.
Okay.
You sounded so confused.
Diverge because I said so.
Yeah. He just showed us like, hey guys, you can't do this test.
Me enjoy my day.
The end.
Okay, so the next one is gonna be this one. You can try this one. This one maybe infinity. Now you do need to know some basic derivative skills here because it has some algebra skill you need it.
Oh no.
He said basic algebra skills. Guys, remember yesterday.
Right.
Remember yesterday.
What? Nothing happened
The
yesterday.
first step. I mean, like when he's talking about Elon Musk. That yesterday.
Oh.
You remember that?
Yeah, but this one's a little bit harder than that.
Do you get even like conjugate or like what?
No.
Oh, okay.
Oh, you just test if the alternative series test. You pass alternating. Do they go to 0? And then are they decreasing?
Well, I got a number.
Infinity, so
0.
over 1 is
So in 2, I get 1 over 1.
Yeah, but the-
over
Is it decreasing?
and
No.
I'm on the second step,
0,
which is
so it
saying that.
No,
and
even
then the third one n plus
Say.
5
It's decreasing.
diverge.
Oh wait, maybe
Dun, 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 dun.
I have to do the third test. I don't know. It's a derivative test.
A n plus 1. That's gonna be 3.
Equals
Root 2 and get all it. I can also
Yeah.
Then 1. Oh, it's
1 over.
Yeah,
2 over 1.
Wait, hold on. I need.
See on this guy's very. 2 words. 3 words.
Okay, so
Yeah.
So is this alternating?
Yes.
Yeah.
Okay, so this is easy to test. So second one is limit n approach infinity of square root n plus 1 over n minus 1
0.
is equal to 0. Yes. So in the second condition pass. The third condition says it's decreasing. It's hard to justify this increasing or decreasing. So I'm gonna take a derivative. So it'll be x plus 1 over x minus 1. And then I'm gonna take a derivative because it's really hard to plug in and knowing absolutely they are always decreasing. So the best way to test, unless you want to prove that n plus 1 situation, but for this case is actually harder. So if I do take a derivative, low, d high,
High. D.
high. Well, I'm just gonna do 1/2 power. So x plus 1 to the 1/2 power, d low over low low.
Hello. That's so much more work than looking at. Yo, and then you just cancel them out.
What you can do is back out the most negative. You learned that last year.
I remember that.
So that's gonna be x
Oh, yeah,
minus
that's the
1
same.
I was just thinking about.
minus, oh, there's a half, sorry, there's a half here and a half because there's half in there, and minus this one gonna
Minus
be
one.
x minus 1 over x minus 1 square.
Why is it minus? Oh, okay. I get it now.
So x minus 1 here square, and x plus 1 to the half. But eventually the bottom's always positive because square root does not cause a negative sign. And this one's going to be 3 over 2 x minus 3 over 2. Now, if I do number line test from 1 to infinity,
Good luck.
on the bottom it's always positive. Always positive on down here, okay? And here I can plug in any number there. It's always negative, so it's decreasing. So therefore, this particular case is going to be converge because AST, and those 3 conditions listed. Okay, how much time we have?
Like 2 minutes.
We have 10 minutes.
I'm gonna give you homework so you can do earlier. So I know some of you guys have work.
I got you mean like a job?
I got the
training email. Apparently we do it for like we have different uniforms.
Yeah, it is a different shirt apparently. I don't know if they signed me up for training.
Okay, does anybody need me to airdrop you homework?
If you forgot the homework existed.
Oh well.
Airdrop me.
Can you explain the shirt? Are you sure?
Oh,
Yeah, what does rap mean? Like I never.
Yeah, I was confused on that too.
I don't know. You're acting like I know. It's something in Italian. It's like an Italian slang.
Yeah, for.
I don't know.
I forgot.
You're in the honor society.
No, yeah, they told us, and then we have.
I think you have to choose for the big jaguar.
Okay, so the question is gonna be 5 to 23 all.
23.
5 to 23.
There's no 23.
I give you 2 pictures.
Oh, there is a 23.
Oh my gosh! If I just scrolled
I
right.
turned it off because last time.
Okay.
there we go.
5 to
It's on.
23. But that, no way. Okay.
Okay, that's 3.
It's iPhone.
Yeah, I'm there.
It,
I
oh,
would
it
like to
does
say
say
that
there.
23 doesn't make sense at all. So
Just don't look. It's not there.
Hey, Andrew, they didn't schedule me.
23 doesn't
Andrew
exist.
didn't schedule me.
Oh, that's bad.
Are you down? I'm really bummed actually.
I gotta check my UKG right now.
Check your
United Nations what?
Checking it
Oh,
right
did I
now.
tell you? I told you. Did I tell you?
I
No, I
checked
have.
my UKG.
I have a fucking.
Can't wait for work.
Get a minute. You're lucky.
By the way, tomorrow, tomorrow we're gonna talk. I will actually give you a review sheet a little bit earlier, so you guys can work on it. So I will including the review sheet today, but you're not able to do all the stuff on review sheet. So, just you have to. Tomorrow we're gonna talk about the error, and we're gonna talk about the absolute and conditional convergency. So that even today, alternative harmonic is a converge, but it's actually not a absolute converge. It's actually conditional converge. So we will talk about conditional and absolute tomorrow, and also the error. Error is going to be the hardest part to understand.
Margin of error?
Yeah, there was an error about your approximation, and we're gonna figure out what the error is. That's why we're gonna move the test to Thursday or Friday. We don't know which day, depending on how much we can
You're
finish
only
the error
moving it,
tomorrow.
but it's-
But I will give you a review packet of everything that can possibly on there, and you can learn from it.
Review packet.
Yeah, that's a,
How many juniors are in Cal PC?
3.
all the
All the ones who were in AB.
Are the cool one.
It's not.
Said I'm included in the pool, Marie. Yeah.
Oh my gosh, yeah, YouTubers can like cry. That's kind of crazy.
No, we can't think See, I've been
It's
having
like,
a
it's like, it's like just us. two.
What?
Us two, they were-
On the first page, on the right.
And then my dad got a new car and he was like,
do a
"Here,
car
this
swap.
I don't know what car you're talking
I
about.
drive your car home, you drive
I know.
Yeah,
Oh, I think that's me and the driver.
On the first page, we just do 5 to
Flip more, like I'm driving.
5 to 21 odd.
What?
Yeah, just odd.
Yeah.
Oh no! No, you almost tricked me. It's 5 to 23 odd. It's not that hard.
There's like almost no.
No, oh.
And after some-
Yeah, they're not that hard. They're not that hard. If they are hard, I understand.
So why
No, but when you collaborate with these like
Yes.
yeah.
No, you did it for them and it's not
already going anyway.
It's when you
Yeah.
get there, like,
Wait,
you're
where's
so
the
hard. Yeah, it's like,
Me.
What?
I jumped in today. What do you mean?
You gotta neighborhood, you gotta get
I'm so.
I go through ayahuasca.
Yeah.
Is that how you say that word?
Ayahuasca, yeah.
Please.
I was see.
What do you do? Ayahuasca, do you want to get to her house? Went to Coraline with the.
Zach.
No, you mentioned it's over time.
Exactly.
Yeah, I feel like you left her.
I tipped at the hood.